lot of cool projects that have come out of it, but it can kind of feel like a minefield sometimes for vulnerabilities. And Sway is a Rust-based DSL for the Fuel VM, and it's built with lessons learned from Solidity in mind, specifically for a developer experience. So really quick, what is Fuel? Fuel is a modular execution layer. You can execute on Fuel and still settle on Ethereum. And it uses a Fuel VM, which uses a UTXO model that allows for parallel execution. So you can have super fast execution for your contracts. So when you're developing with Solidity, you're probably going to use a lot of independent tools. You'll probably, for developing, you'll use Hardhat or Foundry, or maybe Scaffold ETH if you're here for that presentation. For the front end, you might use Ethers.js and Web3.js. For your indexer, you might build your own custom indexer or use something like the Graph. And with Sway, so Sway is developed by Fuel Labs, and Fuel Labs also develops like a whole suite that's totally integrated with Sway. So you have Fuel Lab, which is a toolchain manager, and you can install Fuel Core, which is the VM core software client, and Fork, which is sort of like the equivalent of NPM. You can use it to create a new project with Fork New, build your project with Fork Build, and deploy with Fork Deploy. There's also Rust and TypeScript SDKs that are specifically meant for Sway, and a Fuel Indexer service. A little bit more about the difference between these languages. So Solidity, you can really just write contracts. And in Sway, there's 4 types of programs. There's contracts, libraries, scripts, and predicates. So here's your like really basic Solidity contract. Has a public string called greeting, and the value is hello world. And real quick, if you notice that there's just this greeting in here, but if you're familiar with Solidity, you'll know that there's a getter function that is generated for this. So you can read the value of greeting automatically. With Sway, instead, it's really like more what you see is what you get. You can see everything that's included in the contract, so there's no getter functions automatically generated. So we have this get greeting function. And you'll notice that the greeting here is just sort of inside the contract. But for Sway, all persistent state variables are stored into storage block. So it's super organized. You can see everything in that storage block that's going to be persistently stored. And it's not going to be sprinkled in between the functions, so you have to like remember where all of your persistent variables are. And another thing about this is if you were going to use this greeting variable in Solidity, you could just use the word greeting. But in Sway, you use this storage.greeting. So that helps with namespacing all of these variables, so you're not going to accidentally call something else greeting and forget, like, oh, there's a persistent variable somewhere else that already has that. And another big difference you'll notice is there's this like hashtag storage read annotation. So all functions in Sway are pure by default, versus in Solidity, they can access storage, they can read and write by default, and you have to say when they are pure or read-only. So that's sort of all of these differences here. Syntactically, Solidity is really influenced by C++, Python, JavaScript, and Sway is really close to Rust. And yeah, in Sway, what you see is really what tells the whole story. There are no hidden functions. Everything in the storage block is what is going to be stored persistently, and all the storage variables are namespaced. Another really cool thing about developing in Sway is that we have a standard library. So like I said, there's different program types for Sway. You can have contracts, and you can also have libraries. And they're sort of like libraries, how you would think of them in other languages. And this sort of generally replaces a lot of global variables in Solidity. So there's a lot of stuff in the standard library that comes out of the box, but you can also specifically import this stuff. Sort of like if you know React, you can import use state, use effect from React, but it's sort of there out of the box, right? So here's an example of a contract that in Solidity uses global variables, and in Sway we can use the standard library. So this contract has an event, uses this event keyword, and the event is called log, and it just logs a number and a string called message. And there's a function called logger, and it emits this event. And in Sway, you can import a log function from our standard library, and it's just this really simple log function where you can just log a value. You don't have to set up any events or anything. One really cool thing about Sway is that is just how you can work with tokens in your contract. So in Solidity, you'd probably use a ERC20 contract from OpenZeppelin, and you have to use these approve and transfer functions. But in Sway, you can actually mint native tokens that you can just transfer in a call, just like how you would transfer ETH or Matic on Polygon or something. So here's that ERC20 contract for how you'd set this up in Solidity. And in Sway, you can import this mint function from our standard library and just call this function to mint tokens. And the tokens will have an asset ID that is the contract ID. And what that looks like when you're receiving tokens, so in Solidity, you can only receive the base asset for payable functions, and you can use this message.value global variable to access the value sent in the call. And in Solidity, because you can send, in Sway, because you can send any token, we have two functions here, message amount and message ID from the standard library that you can find the amount sent in the call, but also what asset is sent in the call, because it could be any asset. And we also have this payable annotation here with like Solidity. So another really cool feature and difference between these languages is pattern matching. So in Solidity, if you are, let's say you have an enum and you want to check all of the values, you could use an if-else statement or a ternary statement. But if you miss one of those options, the compiler will warn you, but it will still build. And in Sway, if you miss one of those options, it won't build. It will make you address all those options. So here is what that might look like in Solidity. You have this enum called weather. It could be sunny, rainy, or snowy. And this contract builds. Like, there is a warning saying that, you know, weather.snowy is not addressed, but it will still let you deploy. Versus Sway will not let you deploy. And it has this exhaustive pattern matching system at compile time where you know all of the options are addressed. All right, and last, I'm going to talk about reentrancy and reentrancy guards. So this is a tweet that says, yes, reentrancy hacks are still a thing. And it's this link to this GitHub repo that has this history of all reentrancy hacks since 2016. And it's quite a long list. It's quite a large amount of money that's been stolen because of reentrancy hacks. So this is a huge problem that Fuel Labs really cares about. And in Solidity, if you're compiling a contract that's vulnerable to reentrancy, it will compile without any warning. And in Sway, the compiler will detect these reentrancy vulnerabilities and let you know, like, hey, you should probably move this because this is vulnerable. And when it comes to reentrancy guards, in the EVM, you would use something like this. So you can use storage to have this locked variable here and like essentially execute your function within this no reentrant modifier. But it's a little bit expensive, right? You have to use storage. So in the Fuel VM, you can actually directly access the entire execution context of a call, which you can't do in the EVM. So you can just directly look, has this transaction called my contract before? So this is sort of what that looks like. So this is using a library called reentrancy, and it has this reentrancy guard function. And inside that library, here's what that looks like. It's just this require statement requiring that it's not reentrant. And it's a little bit complicated here, but essentially what this is doing is looking at the call stack and looping through it and seeing if this transaction has already called our contract. So we can directly see here if there's reentrancy without using any storage. And yeah, if you want to check out more one-to-one Sway versus Solidity examples, you can check that out with this QR code. We also have a really cool developer quick start. You can build a counter contract, full stack, and with our TypeScript SDK, and we also have this marketplace tutorial. You can build sort of an Amazon-like marketplace with Sway. So yeah, thanks. Let me know if you have any questions. Yeah.